We're taking a look at the Quiz 8 preview today. Again, going to be doing some stuff like we have been, especially with the factoring. So hopefully now we've seen enough practice that this is going to make life a little bit easier on us. So again, I see 4 terms. I'm going to pair them off. I'm going to take out the greatest common factor of each pair of terms. Not always going to be numeric. Sometimes it can just be a variable term. And then whatever I've got left, I'm going to go ahead and get into my parentheses. Now remember, if I do this right, the set of parentheses needs to be the same for both. So I look at the second pair and I'm like, well, there's really nothing they have in common. But I always have to pull out something. So if I don't see anything else, I'm going to pull out a 1. You're like, well, the 1 just keeps that the same. Well, that's okay, especially in this case, because there's my common terms that I can now work with. So again, my solution then becomes my common quantity, but again, write it once. And then my greatest common factors. Now be careful. I know we've run into some cases where this will break down. And you're even going to look at this and go, ooh, perfect squares, I can break this down. But remember, when we're dealing with perfect squares, there's only a difference of squares. This is a sum. There's a sum when I'm doing cubes, sum and difference, but that's going to be it. So I have to be careful of that and watch out for that. Just something to think about. When I get to number 2, look to see if there's something in common. Yeah, not in this case. Okay. So since that's not the case this time, I look and I go, oh, they're both perfect cubes. So I write down what I cubed to get each of the terms. And again, that's a step I really think is critical for a lot of you to be able to make it through the kind of our little formula that we have for this, our pattern. And again, the pattern goes, write my breakdown terms, use the sign in the middle. And then here again, here's how it goes. Square my first term. I square the 2 and the x. I change signs, so if my first sign's plus, I go to minus. I multiply these 2 guys together. And then I square this last guy. And I'm set. Nice thing about cubes, they don't break down anymore. I can just leave them be. Number 3. Again, same idea. You might look at that and go, well, that's x to the 4th, though. Remember, that's like doing 16x squared minus 49. It's a difference of squares. The difference is going to be, if this were 16x squared, I'd do 4x plus 7, 4x minus 7. But there's one small change. X times x gets me x squared. What times what gets me x to the 4th? X squared. Now again, be cautious. You're going to look and you're going to go, ooh, 4x squared is a perfect square. But 7 isn't. If that was 9, I could break this down. Okay, or 16 or 25, some perfect square. But it isn't. So I'm done. So let's take that idea of looking at the 4th like it's a square and use that for number 4. Same thing, treat it like it's x squared minus 10x plus 16. It's just a straight up diamond problem. X squared, multiply to 16, add up to negative 10, negative 8, and negative 2. No perfect squares to break down anymore, I'm done. Okay, a lot of these can keep it simple. I just have to be aware. Nothing in common, perfect square, perfect square. 3x and 10. Again, difference of squares. First term, last term, plus, minus. Okay, not minus 10 squared, because I've got to have a positive and a negative to get a negative product anyway. Those are the little things I have to be on the lookout for. So then I get to 6. And some of you are thinking, ooh, slide and divide right away. But wait. The golden rule is upon us. What do those 3 terms all have in common that I could take out? they all have a 4. By taking out that 4, not only am I going to have smaller numbers to work with when I factor, but I also now get to do a diamond problem instead, which makes this go quicker. I want two numbers that multiply to negative 16, so I know one's negative and one's positive, and that add to negative 6. Now again, when I add to negative 6, the bigger number has to be negative. So 8 and 2 are 6 apart, and then I just stick that 4 that I had at the beginning back in, and I'm set. So as I do these, I just keep working and go, okay, so I look at the next one, perfect square, dealing with it just like we did back here on number 5. What do I square to get each one? I square x to get x squared. I square 8y to get 64y squared. And I really think something as simple as doing this little bit up here is really going to help some of you to not do something silly, like just write down 8 minus x minus 8y and think you're done. Plus, minus. You've got this. Even though there's some different parts, again, the more practice you get, you start looking at, oh, squared. That's a difference of squares. Oh, cube. Here's the pattern, okay? Again, what's in common? Always look for that first. Like I can get a 3 out, okay. What about variable terms? Because they all have one. Take the smallest one you see. It has to be x to the third. It can't just be x. So have x to the third, need to get x to the fifth. Have x to the third, need to get x to the fourth. And then 3 times what gets me to negative 60. And factor what's left in there. Again, it's just a diamond. Multiplying to a negative tells me I get one of each. They're going to be one apart, and the bigger number is going to be positive. But don't forget to bring this back down, because otherwise it doesn't multiply outright. So then I get going a little further. I'm like 343 and what? Oh gosh, I don't know how to do that. I don't know about 343. I see it's a cube, so it probably is, but I don't know what the cube root of 343 is. Okay, here's my option. And let the calculator help me if I'm not sure. Now, there's not a definitive, at least not on our calculators, a cubed root button. So here's what we do instead. If you ever have something and you're trying to figure out a cubed root, that's the equivalent of taking it to the 1/3 power. So if you're not sure what that is, you always have this as an option to figure it out. So 7x and 1, because I need those two values to be able to do my cubic. So here we go. 7x, take the sign in the middle, and here goes the pattern again. Square my first term, the 7 and the x. Change signs. Multiply the two terms together. Square my last term. Good to go. But you've got to know the pattern. If you don't know the pattern, I'm not going to be able to help you much. And then one more, and we finally get to get away from this for a little while. Again, remember, take out the greatest common factor. So I can get a 3, and I can get the x squared. Already got the 3. X squared to x to the third. I need one more x. 3 times what to get to negative 15? Negative 5. Then over here, I'm like, okay, so 4x and 20. That negative usually puts up signs. I'm probably going to have to use it, so let's try that. What if I use negative 4 here? Negative 4 to get to negative 4x is just x. Okay, so far so good. Negative 4 times negative 5 is positive 20. Good, I see my match. So again, my solution the common quantity, the common set of parentheses, x minus 5, and put those together. Okay, and I'm set. Finally, we get away from factoring for a little while. Okay, find the inverse. Again, switch x and y, and we're going to be solving for y. So again, smart thing to do, go ahead, get that fraction out of there. Don't divide first, get the 5 out of there first, so subtract it over. Then divide. And again, we want to put this in a form where if I was asked to graph it, I could. Now, would I mark it wrong if you put 4x minus 5 over 3? No, but if you're asked to graph, you're going to want to know how to get to this way anyway. So I'm just saying. So I'll get that on there, and I'm set with that. Again, once y is solved for, I'm good. So then we see if we can apply it. Draw an example of a graph whose inverse is not a function. Remember, function equals it goes through one point on your graph. Not a function equals more than one point goes through your graph. And again, that's with the horizontal line test. So if I want one that's not a function, I don't know, maybe I just draw some funky looking curve like this. And then it goes. How do I know that the inverse of this graph is not a function? Depending on what picture you drew, horizontal line goes through more than one point on my graph. If it only goes through one, okay, the inverse is a function. I've actually better put that here. Inverse is a function or not a function. It doesn't mean it's not a function as a whole. This would pass the vertical, but for seeing if the inverse is a function or not, it wouldn't pass. But again, any picture would work, but read carefully, because tomorrow I may ask not, I may ask is a function. Depends. So read carefully. Okay, prove that f of x and g of x are inverses, show work. F of g. Remember, that means we are plugging g into f. Write the steps so you see it, which means g of x so I'm going to literally plug this in for that x. So -3, plug in what's in the parentheses for x. Everything else stays the same. Distribute my -3 through. Negative times negative is +1, so that would be x minus 6, -3 times 2, plus 6, but then those cancel. And just give me x, which that's supposed to happen if they're inverses. Once I've done that for f of g, I switch it up. F of x is -3x plus 6. So again, I'm literally going to plug this in where the x is at. Okay, only replaces the x, but it replaces it. It doesn't times by it or anything else. The x is out and what's in the parentheses is in. Distribute through. -1/3 times 6 is -2 plus 2. And we've proved it. So again, I got to watch for this. I got to think about it a little bit. But again, I've got to prove that they both equal x. If one of them does not, then they're not inverses of each other. All right, to the back. Simplify. Okay, keep life simple, people. That's a minus sign. Do not put some big 3 by 3 box or multiply all these things out. We're not multiplying. We're subtracting. So in other words, I leave the first quantity alone, and this minus just changes the signs on all three of these. I'm running out of ink. All right. So what I'm going to do at this point is I'm just going to go back through and combine like terms, going from the largest degree and working my way down. Negative 6 plus 8 is positive 2. The 7x is my only x term. And negative 11 minus 11 doesn't cancel. It's minus 22, and I'm set. So then I get to my binomial expansion. Now again, could you write out x minus 7 3 times, FOIL it out, and then distribute it out again? You could. I really don't want you to have to do that. So remember, with my Pascal's triangle, if I can build my triangle up, so this is my 0, 1st, 2nd, 3rd. Okay, this is my x cubed line. So my pattern for this one is a cubed plus 3a squared b, because again my a value goes down 1 degree each time. My b is going to go up, plus 3ab squared plus b cubed. A is down 1 each time until it disappears. B is gone at the start, so b to the 0, b to the 1st, b to the 2nd, b to the 3rd. And so now I just look at these, and I have my a and my b terms. So I go, okay, so x cubed plus 3x squared times negative 7 plus 3x negative 7 squared, because again, a and b, plus negative 7 cubed. And then I just simplify the different pieces. 3 times negative 7 is negative 21x squared. 49 times 3 is 147x. And negative 7 cubed is 343. And I'm set. Now again, if you don't know the pattern, you're going to have to multiply all that out. So just kind of think about that a little bit if you're deciding whether you really need to know Pascal's triangle or not. All right, number 16 here. Neighborhood kids want to build a tree house and decide to have a bake sale. There you go. The revenue from the sale of x pies is given by r of x equals 10x. Okay, that's how much we're selling each pie for. Suppose the function for the cost of making x pies is p of x, equals 4.5x plus 15. What are the pies selling for? Again, not a tree house, not a bake sale. $10. The revenue, how much am I taking in per pie? $10. 10. Okay, write the profit function. Again, revenue. I learn how to spell. Minus cost. Let me put that in parentheses to remind me. Okay. The profit function is my revenue minus my costs. I have to have the parentheses. If I don't, I'm going to have plus 15 at the end and I'm not going to get the right answer. Distribute it through. Again, I would even suggest so far is to actually write it out so we don't do something silly. Combine my like terms. Profit function. See why I needed the parentheses? Okay. Once I simplify that, the profit on 50 pies shouldn't be bad at all. So once I get there, let's see here. Oh, no, I can do this. I'm going to have confidence in myself. So 275 minus 15, $260 profit. That's what we're working. Okay, functions. Now this has been a stickler for some of us. We're going to try and clean some things up here. We have an f of x, we have a g of x. Write an expression for each function, state any domain restrictions. Okay. F plus g of x, simply stated, means I'm taking f of x plus g of x. In other words, write those two things down and combine their like terms. So x squared minus 1 plus x plus 3. Find the terms that are alike. I don't have any other x squareds. I don't have any other x's. Negative 1 plus 3 is 2. That's it. You're not multiplying by x. Okay, some of you still are wanting to do that. That's why I want you to actually write out what it means so you can see what it is, work that out, and not have that at issue. Same thing working with 18. F times g of x. F of x times g of x. Foil or box these together. I'm literally going to multiply them together. Not time to go yet. So again, whether I do this, so I've got my first x squared times x is x to the third. My outer plus 3x squared. My inner minus x. And my last minus 3. If you want to do a box to do this, you can. Okay? But again, I'm just multiplying them together. I do not finish and then times by x. We have never said that, and we will never say that going forward. Now we've got our composition. That's what the open circle is for. This says f of g of x. In other words, I'm going to plug g of x into my f function. So again, do this in steps. You'll keep yourself out of trouble. F of my g of x is this. Rewrite it so you know what you're doing. Now that I've done that, my job becomes to stick this x plus 3 in where the f is at. Okay? So that means I'm going to do x plus 3 squared. This replaces the x minus 1. Now, I believe the only dilemma we are going to have left here is some of you wanting to distribute this and make it x squared plus 9. And so help me, I'm going to start bashing my head against a wall if many more of you do this. So, if you need to, scratch paper, side of the page, whatever it is, work it out. X plus 3, x plus 3. If you want to make a box, I need to do it. All of the step skipping needs to stop. Because we're doing things that aren't being shown to you. We're just kind of making up things as we go, and you can't get away with that. It doesn't work. There's a middle term involved here. So it's x squared plus 6x plus 9. Don't forget about the minus 1 that's there. And combine like terms. We are starting to get into real Algebra 2 honors mode. There are going to be multiple steps. There's going to be multiple things going on. You've got to work through them and work with them. The days of skipping everything and blowing through just off the top of my head are done. So the quicker we understand that and learn that, the better off we're going to be. Last one, f divided by g of x. Okay, f of x divided by g of x. No, you cannot cancel. Let's do this. Okay, unless they're identical, we're not canceling anything. But State any domain restrictions. We haven't had any so far because the only time those happen are when I have a denominator, which I do here, we'll get to that in a minute, or if I have a radical with an even index, square root, fourth root, something to the 1/2 or like 1/4 power. But here, this can't be 0. So I make sure it doesn't equal 0. So x cannot be -3. Gotta remember that part. All the rest of them, it's fine. As long as one of those two situations aren't arising, we can go about it that way. Okay. 21, find p times q of 7. Again, let's write this out. P of 7 times q of 7. Literally, plug 7 in for x in each function and then multiply the answers together. So for instance here, if I plug in 7, 2 times 7 is 14, plus 3 is 17. Absolute value of 17 is still 17. Okay. Plug 7 in for x. 2 times 7 is 14. 4 minus 14 is -10, and times them together. Okay? Plug the number in. Same thing on 22. Ooh, we're even going to put a composition in here. Okay. Q of P of -2. Here's how this works. Normally, we would have Q of P of X. That's how this would set up. But I have a value in here instead. So, this becomes Q of P of -2. You're like, okay, so what's that mean? Well, what's P of -2? If I stick -2 in here, 2 times -2 is -4, plus 3 is -1, but its absolute value of -1. So this piece of -2 equals 1. So once I find this value, that becomes what's in the parentheses. So at that point, I'm finding Q of 1. In other words, stick 1 in for x. 4 minus 2 times 1, or 4 minus 2, is 2. One step at a time, figuring out the individual piece until we get to the end. Patience. 23, a little review. Okay, sketch -2x squared minus 1. Now again, here's a hope, but there's an option. This tells me where my intercept would be. My y-intercept, that is. -2 means it's opening down, and my slope, air quotes, would be -2. Now, if I don't remember how that pattern works, I always have my backup plan. Backup plan's never a bad thing. I can always go here. See my graph, all right. But again, I'd want to find my symmetry, and I see it on the y-axis here. So I could always plug it in here, and take my values off of there. It's legal. My domain, forever left and right. We've been saying forever. That's the domain every time on these, so it's not a surprise. My range, bottom to top with y's. Bottom is going down forever, -infinity. To top, y value, -1. End behavior. My x's, I will always have one going to -infinity, one going to +infinity. Just a reminder, what does that mean? As x goes to the left, what's happening to y? It's going down. Or I could go back to my odd even. Even, opening downward, and I could remember it's down, down. But if I don't, I can always do it visually like I'm doing it right now. As x goes to the right, what's happening to y? Because that's what f of x is. It's going down. So again, you've got options, and it all is starting to pile up here. So if we're starting to kind of a little bit with homework and stuff, not a good time to be doing it. And then the last couple here of what we've been doing. Graph f of x and the inverse of x on the same graph and label. Okay, f of x is 4x minus 2. Minus 2. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1. 1, 2, 3, 4, 1. Now, I'm going to make mention of something here in a second, but for now, I'm just going to get that graphed. To find my inverse, remember, f of x means y. To find the inverse, we switch the x and y, and we solve for y. Add my 2 over, and divide by 4. But again, I want this in a form where I can graph it. So I've got 1/4 x plus 1/2. Now, some of you might not feel comfortable graphing when you've got the fractional stuff. If you do, go ahead and just graph the line and be done. But what if you don't feel comfortable? Here's your other option. When I graphed my first line, 4x minus 2, look at the points that you plotted. Even jot them down. So like I've got a point at 310. I've got a point at 2, 6. I've got a point at 1, 2, and 0, -2, and -1, -6, and -2, -10. Again, inverse, switch. So when I'm going to do this, another option I would have is just flipping the x and y values, inverting them, and plotting those points, and I would get the same line. Now again, if you're comfortable using the slope-intercept form, then do it. But otherwise, that's the other way I can get the inverse graph of what I have. Just an option. And then finally, one more inverse. Find the inverse of this. Switch my x and y. Except that actually has to be a y if I want it to be y. That would be important. Minus my 5 on over. And again, this is just me. If you wanted to multiply by 7 and then divide by 2, you could. But I'm more of a fan of using my reciprocal. And then distributing it through. 7/2 x minus 35/2, because we don't use decimals when we're getting ready to try and graph a line. Okay. Again, this is one of those quizzes you need to come in ready on it. You're not going to have time to sit and stare at it and go into outer space trying to wonder what if. You see what it is. You know how the quiz is working here. Basically, you've got the quiz right now. Go back if you need to, watch this, watch other sections, look at your notes, grab an extra copy of this and do it again. I don't know what it is, but between this and the homework, we've got enough practice for you to be good at this. So be sure that you put the time in, and if you have, it should go well for you.